Okay, this is Dr. Williamson. I want to solve some stoichiometry problems in a slightly different way than what you're used to. And maybe this alternate way will be easier for you than the other way, than what's called the dimensional analysis way. And if this way is easier for you, great. If it's not easier for you, then ignore it. Okay. So the first thing I need you to do is take a look at this balanced chemical equation. And in this balanced chemical equation, what I need you to understand is the relationships here is I have an invisible understood 1 for a balancing coefficient. This is a 2. This is a 2. And this is an invisible understood 1. And all of these balancing coefficients are mole relationships. This says 1 mole of PbOH2 will react with 2 moles of HCl to produce 2 moles of water and 1 mole of PbCl2, lead 2 chloride. So these are all mole relationships, not gram relationships. Okay. And to solve some of these problems, I went ahead and put the molar masses up here. I did these all to 2 decimal places. So here's what I did. I wrote down some problems, and here's what we're going to do. In the first problem, to illustrate this ratio and proportion method, it says how many moles of lead hydroxide are required to produce 10 moles of the lead chloride. So it's between the lead hydroxide and the lead chloride. Whenever you see something like that, that's code talk for you can temporarily ignore the other 2 guys. Okay? And whenever it says how many moles of something, that means you have X here. That's what you're solving for. And you want to get 10 moles of that thing here. So I'll write 10 moles. Okay. And I'm going to erase that. Oh, I did not intend to do that. See if I can erase this. No, can't do that. All right. Well, I guess I'm stuck with that bracket. Okay. Okay. So I'm going to put what I'm solving for on top and what I'm given over here. And then underneath, I know that I have for every 1 mole, this is exact here, 1 mole of PbOH2, I get 1 mole of PbCl2. So I'm going to end up with a simple X over 1 mole is equal to 10 moles over 1 mole. And then I multiply both sides just to kind of keep the algebra. 1 mole times 1 mole. I'm being silly here just to keep the algebra straight. So these cancel, right? And I end up with X equals 10 moles I'm going to end up with the number of moles of lead hydroxide needed to produce 10 moles of PbCl2 is 10, which makes sense because if it's 1-to-1 relationship, and I want to produce 10 of these, I'm going to need 10 of those, right? It's on a mole relationship basis. That's kind of straightforward, right? Well, here's where it gets a little more helpful. Hopefully I can erase stuff without erasing my equations. Okay, that looked pretty simple, right? Easy. But let me show you here. All right, let's look at the next question. Right, we did this question here. We did this one, cross that one out. How many grams to produce 15 moles? So it's still between this guy and this guy. So here we're going to write X grams of lead hydroxide. And we want to produce this time 15 moles of lead chloride. Well, this is still 1 mole underneath, and this is still 1 mole underneath. And since I have moles on top, I can leave this moles underneath here. But this is moles underneath here, but I need it to be in grams because this is in grams. What am I going to do? I got the 1 mole because of that 1. I'm going to convert this 1 mole into grams using its molar mass. I've got lead hydroxide, 241.21 grams per 1 mole. So now when I do my ratio in proportion, I will have X grams, 1 mole times that 1 mole, I will have 241.21 grams will be equal to 15 moles over 1 mole. Moles cancel out. X grams will be equal to 15 times, I'm not going to cancel out the grams because I bring it over here. In algebra, I bring it over to 41.21 grams equals 241.21 times 15. We get 3618. 36. Go to 3 sig figs. 20 grams of PbOH2. So over here, my given was in moles, and since this is in mole relationships, I left it in moles top and bottom. What I was solving for was in grams, but this is in mole relationships. So I took my 1 mole, because this is a 1 right here, so I have 1 mole. I turned it into grams using the molar mass. So I did that, turned it into grams, and then I was able to solve. I'll do another one, and then I'll do 1 more yet after that. Let's get the eraser here. See if I can do this without messing up. So let's instead of doing this, well, we did this one. Instead of doing this one, let's say we said, how many grams so we'll go X, how many grams of hydrochloric acid are needed to produce, let's say, 100 grams of lead chloride. Let's say I wanted to do that. Well, this is in gram relationships, but this too is in moles. So I'm going to write X grams of HCl over 2 moles. Because of this 2 right here. And that's in moles. But I need to turn that moles into grams. HCl is 36.46 grams per mole. 36.46 grams per mole equals 100 grams. Put a dot there to make it 3 sig figs. That's lead chloride. And this 1 right here means 1 mole. Because it's always mole relationships. And I need to turn that 1 mole into grams because I have grams up here. Lead chloride is 278.09 grams per mole. Terrible writing. It's supposed to be a mole. Okay. But when I do that, 2 times 36.46, 36.46 times 2, it's going to be 72.92. So I'm going to have X grams times 72.92 grams is equal to 100 grams, because these moles cancel these moles cancel these moles. 278.09, 1 times that, 278.09 grams. I'm going to cancel these grams with these grams. I'm going to multiply both sides by 72.92, just like you're supposed to do in algebra. 72.92 grams. That way this crosses with that. Right. And I will have X grams is equal to 100 times 72.92 grams over 278.09. So times 100 divided by 278.09. And that's going to give me 26.2. grams of HCl. I didn't cancel all the grams. I didn't cancel these grams with these grams because I knew I was going to need some grams when I was done. Okay, so I remember that. I needed to remember that. And I needed to remember that I was solving for HCl, so I needed to remember the label. So that's called the ratio and proportion method. You may like this way. If it clicks with you, great. If it doesn't click with you, then you can delete it and not do it. But I just thought I would show you an alternate method, just in case you like it. Well, anyway, if you have any questions, let me know. Okay. All right then.